Hi friends, today I am giving a lecture on 0 by 1 knapsack problem using backtracking. Okay, so 0 by 1 knapsack problem is discussed in greedy method, dynamic programming and branch and bound. Okay, now in this video we have to discuss about how 0 by 1 knapsack problem can be solved using backtracking with one example problem. Okay, so this is the given problem. N is equal to 5. N is nothing but number of objects is equal to 5. M is equal to 12 is nothing but capacity of the knapsack is nothing but 12. Next, profits of 5 objects P1 to P5 is equal to 10, 15, 6, 8 and 4, and the weights of 5 objects W1 to W5 is equal to 4, 6, 3, 4, 2. Find out the optimal solution of the given 0 by 1 knapsack problem using backtracking. Okay, in the greedy method we have to know that the optimal solution for fractional knapsack problem can be obtained by using P by W ratio. In the same way, we have to find out the P by W ratio. So that is nothing but 10 by 4, 15 by 6, 6 by 3, 8 by 4, 4 by 2. That is nothing but 2.5, 2.5, 2, 2, 2. Okay, so first we have to place first object into the knapsack, next second object, next third object, next fourth object and the next fifth object can be placed into the knapsack to get the optimal solution for the given problem. Okay, first, the main objective of knapsack problem is to attain the maximum profit. How to attain the maximum profit? We have to place the maximum profitable objects into the knapsack with respect to the weights of the knapsack. Then we are getting the maximum profit. So here the maximum profit is sigma pi xi. So that is nothing but sum of the profits of the objects that are put into the knapsack. So that is nothing but P1 x1 plus P2 x2 plus P3 x3 up to Pn xn. Okay. So this is our main objective is to maximize the profits of the objects that we are placed into the knapsack with respect to the weights. So weights is nothing but sigma wi xi less than or equal to capital M. That is nothing but sum of the weights of the objects that are placed into the knapsack, so that are less than or equal to the capacity of the knapsack. So these are the two main objectives of the 0 by 1 knapsack problem. Okay. So main objective of 0 by 1 knapsack problem is maximize the profit. That means whatever the profitable objects that are placed into the knapsack, from that one we are getting the maximum profit. And also whatever the objects that are placed into the knapsack, sum of the weights of the objects is always less than or equal to the capacity of the knapsack. So these are the 2 points that are keep in mind while solving the given problem. Okay, next one. So the solution vector for the 0 by 1 knapsack problem can be denoted by x. X is equal to x1, x2, x3, x4, x5 because n is equal to 5. So x1, x2, x3, x4, x5. Each xi can take either two values 0 or 1. Okay, for example, x1 can take two values either 0 or 1. x2 can take two values either 0 or 1. x3 can take two values either 0 or 1. x4 can take two values either 0 or 1, and x5 can take either two values either 0 or 1. Okay, so this is the solution vector. So for example, this is one solution vector. Here 1 1 0 0 1. That means x1 is equal to 1, x2 is equal to 1, x3 equal to 0, x4 is equal to 0, x5 is equal to 0. Each xi can take either 0 value or 1 value. So 0 means that the x suffix I is equal to 0 means that object is not considered. Okay. X suffix I is equal to 1 means that object is considered. Okay. What are the objects among 5 objects that we are considered that values are 1? What are the objects that we are not considered that values are zeros? Okay. So here x1, x2 and x5 objects are considered and x3 and x4 objects are not considered. In the second solution, so x1 and x3 objects are not considered, x2, x4, x5 objects are considered. Okay, so this is solution 1 for the given problem and this is the solution 2 for the given problem. For the solution 1, the maximum profit is 29. For the solution 2, the maximum profit is 27. Our main objective is maximize the profit. Among them, what is the maximum profit? That is 29. So 29 is the maximum profit and so this is the solution. This is the optimal solution for the given problem. Okay. How we are getting this optimal solution? By using this data for the given problem that we are discussing first. Okay. So before going to this problem, here there are fixed tuple size formulation. So what is fixed tuple size formulation? That means each xi can take two values, either 0 value or 1 value. So that is nothing but fixed tuple size formulation. Each and every node in fixed tuple size formulation can take two values, either 0 value or 1 value. Left child can take 1 value and the right child can take a 0 value. Okay, so this is called as fixed tuple size formulation and also dynamic state space tree. Okay, now we go for this problem. So here this problem starts with a state space tree. So state space tree is nothing but what are the solutions for the given problem available. That solutions can be represented in a single tree called as state space tree. Once again I am telling, suppose we are taking a given problem. That problem has, for example, n number of solutions. N number of solutions for the given problem can be represented by using a tree. That a tree is called as state space tree. Okay, so this is called as state space tree using fixed tuple size formulation and a dynamic state space tree method. Okay, so first the state space tree starts with a root node. Okay, that root node contains two coordinates. First coordinate is called as profit coordinate and the second coordinate is called as weight coordinate. So that is P comma W pair. The root node contains two coordinates. First coordinate is called as profit coordinate and the second coordinate is called as weight coordinate. So before starting our problem, so there are no profits and there are no weights. That means there are no objects are not placed into the knapsack before starting our problem. That is, initially we are not placing any objects into the knapsack, so that profit is equal to 0 and weight is equal to 0. So the root node contains 0 comma 0. That means So here first 0 represents the profit value, second 0 represents the weight value. That means there are no objects that are placed into the knapsack initially. Okay. So now, among all the P by W ratio value, which P by W ratio has the highest? Either this one or this one. You can take any one, no problem. I am taking first one. Okay. So first one is nothing but first object. Okay. Now I am considering the first object. So first object P value is 10 and weight value is 4. So first object is consider this one. First object is not considered. X1 is equal to 1 means the first object is considered. X1 is equal to 0 means the first object is not considered. After considering the first object, so what is the profit? That is 0 plus first object profit 10. 0 plus 10 is 10. Okay. What is the weight? 0 plus 4. That is 4. Okay. After considering the first object x1 is equal to 1. So the profit value is 10 and the weight value is equal to 4. Okay. Now we go for consider the second object. That is x2 is equal to 1. Second object profit is 15. This 15 can be added to 10. Okay. So 10 plus 15, that is 25. Next weight, second object weight is 6. So 6 plus 4, that is 10. So that is after considering the second object, so 10 plus 15, that is 25. 4 plus 6, that is 10. So that is this node contains 25 comma 10 after considering the first object. Okay, this node after considering the first object, profit value 10 and weight value 4. After considering the second object, profit value is 25 and 10. 10 plus 15, that is 25. 4 plus 6, that is 10. This is second object. Now we go for third object we have to consider. Third object profit value is 6 and weight value is 3. So 25 plus 6, that is equal to 31, and 10 plus 3, that is equal to 13. After considering the third object, we have to add third object profit to this one, third object weight to this one. Then after that we are getting 31 comma 13. Okay, 31 is the profit value and 13 is the weight value. Okay, what is the capacity of the knapsack? Capacity of the knapsack is 12, but here weight is greater than the capacity. Capacity is 12, but weight of the, after considering three objects, the weight of the capacity is 13, but here capacity of the knapsack is 12. Okay, whenever weight of the objects that we are considered is greater than the capacity of the knapsack, we have to invoke the bounding function. Then we have to kill that node. Okay, after considering the three objects, weight is 13. Okay, capacity of the knapsack is 12. So this 13 means weight, sum of the weights of the objects that we are considered. So that is 13. Capacity of the knapsack is 12. So 13 greater than 12. Okay, so by using the bounding functions, we have to kill that node. So what is the condition? Sum of the weights of the objects that we are placed into the knapsack is less than or equal to the capacity of the knapsack. Here three objects we are considered. Three objects weights is equal to 13. So capacity of the knapsack is 12. 13 less than or 13 less than or equal to 12. So here 13 is this one, 12 is this one. 13 less than or equal to 12. So this is false. It violates the property, that is sigma WXI less than or equal to M. so that we have to kill that node. Okay, so by using bounding functions, we have to kill that node. Okay, so up to now, the tree is extended. From this point, we do not go forward because this node is killed by violating this property. So now again we have to backtrack. Again we have to backtrack. So now here x3 is equal to 1. Now we go for x3 is equal to 0. That means third object is not considered. Whenever the third object is not considered, whatever the values we have there, that values we have to write. So third object is not considered. Profit is the same 25 and weight is also same. Okay. Now we go for fourth object. So now fourth object is considered. Fourth object profit is 8 and weight is 4. So 25 plus 8, that is 33, and 10 plus 4, that is 14. Okay. So here also the sum of the weights of the objects that we are considered is greater than the capacity of the knapsack. It violates this property. So here this weight is 14. 14 less than or equal to 12. So condition false. It violates the property of this one, so that we have to kill the node because 14 greater than 12. So by using bounding functions, we have to kill that node. Now again we have to backtrack. Again we have to backtrack. So now left child is completed. We go for right child. Right child is x suffix 4 is equal to 0. Okay. So this is the fourth level. We have to consider the fourth object and we do not consider the fourth object. So x suffix 4 is equal to 0. Okay. Whenever fourth object is not considered, the same values we are getting. That is 25, 10. Okay. Now fifth object is also there. Now consider the fifth object. How we are consider the fifth object? X suffix 5 is equal to 1. So what is the fifth object profit? Fifth object profit is 4 and fifth object weight is 2. Okay. So 25 plus 4, that is 29, and 10 plus 2, 10 plus 2, that is 12. 25 plus 4, that is 29. 10 plus 2, that is 12. So after considering the fifth object, the profit value is 29 and weight value is 12. So sum of the weights of the objects that we are considered is less than or equal to the capacity of the knapsack. Here the weight value is 12. Capacity of the knapsack is 12. 12 less than or equal to 12. So condition true. And also all the objects are completed. 5 objects are there: x1, x2, x3, x4, x5. 5 objects are completed. The sum of the weights of the objects that we are considered is equal to the capacity of the knapsack, and the profit is 29 and the weight value is equal to 12. So whenever the sum of the weights of the objects that we are considered is equal to the capacity of the knapsack, it becomes the solution. So this is the solution 1. Okay. Now we go for backtrack. Okay, we go for backtrack. Another possibility is x suffix 5 is equal to 0. Okay, x suffix 5 is equal to 0 means, so fifth object is not considered. So that is 25, 10. Okay, so sum of the weights of the objects is less than or equal to the capacity of the knapsack. Here 10 less than or equal to 12. But remaining capacity is 2 is there. But all the objects, 5 objects are considered. Okay, there are no objects are considered. It does not violate the property, but sum of the weights of the objects is always less than or equal to the capacity of the knapsack. This node cannot be extended because all the five objects are considered. Okay, so now we have to stop. Okay, now again we have to backtrack, again we have to backtrack, again we have to backtrack, again we have to backtrack. Now we go for this one. Here left hand side x2 is equal to 1, right hand side is x2 is equal to 0. x2 is equal to 0 means second object is not considered. Whenever the second object is not considered, whatever the p comma w values there, that values can be written same. So that is 10 comma 4. Okay. So after completing second object, p value is 10 and w value is 4. Now go for third object. So x suffix 3 is equal to 1 because sum of the weights of the objects is less than or equal to the capacity of the knapsack. 4 less than or equal to 12. Condition true. Now consider the third object. Third object profit is 6. So 10 plus 6, that is 16. Weight is 3. 4 plus 3, that is 7. After considering the third object, so profit value is 16. 10 plus 6, that is 16. 4 plus 3, that is 7. 16 comma 7. Okay. Now sum of the weights of the objects that we are considered less than or equal to the capacity of the knapsack, so that this node can be extended by considering the fourth object x suffix 4 is equal to 1. So fourth object weight profit is 8. 16 plus 8, that is 24, and 7 plus 4, that is 11. So 16 plus 8, fourth object weight is 8. 16 plus 8 is 24, and 7 plus 4, that is 11. So 24 comma 11. Sum of the weights of the objects is 11. 11 less than or equal to the capacity of the knapsack, so that this node can be extended. Okay. Now by considering the fifth object, x suffix 5 is equal to 1. 1. So that means fifth object considered. Fifth object where profit is 4. 24 plus 4, that is 28. Fifth object weight is 2. 11 plus 2, that is 13. Okay. After considering the fifth object, so the weight is 13. Sum of the weights of the objects that we are considered is 13. So 13 is greater than the capacity of the knapsack, so that it violates the property sigma wixi less than or equal to m. So this value is 13 and this value is 12. 13 greater than 12. So it violates the property. 13. So this value is 13. This value is 12. 13 less than or equal to 12. So that is false. So that apply the bounding functions, so that we have to kill that node. So there is no possibility for extending that node. Again we have to backtrack. So here this side x suffix 5 is equal to 1. Another side x suffix 5 is equal to 0. When we are not considering the fifth object, okay, so the same values we are getting 24 comma 11. 24 comma 11. So here the weight is 11 after considering the 5 objects. So 11 less than or equal to 12. Okay, so we cannot further extend it because 5 objects are completed, so that it is not a solution and it cannot be extended. Okay, now we go for backtracking. So here another possibility is there. Here left hand side x suffix 4 is equal to 1. We go for right hand side x suffix 4 is equal to 0. Okay, whenever we are not considering the fourth object, so whatever the p comma w values are there, that values we are writing same. Here 16, 16, 7, 7. Okay. So now we go for So sum of the weights of the objects that we are considered is less than or equal to the capacity of the knapsack. 7 less than or equal to 12. Condition true. So that we can extend that node. Okay. By considering the fifth object profit value 4 and weight value 2. So 16 plus 4, that is 20, and 7 plus 2, that is 9. So 20 comma 9. After considering the fifth object, profit value 20 and weight value is 9. So sum of the weights of the objects that we are considered is less than or equal to the capacity of the knapsack. 9 less than or equal to 12. So some remaining capacity 3 is there, but we are not considering any object because 5 objects are already considered. So we cannot move forward. So again we have to backtrack. Okay. So another possibility is that x suffix 5 is equal to 0. X suffix 5 is equal to 0 means, so we are not considering the fifth object. Whenever we are not considering the fifth object, the same p comma w values are there. So that is 16 comma 7. Sum of the weights of the objects that we are considered less than or equal to the capacity of the knapsack. 7 less than or equal to 12. Some remaining capacity is there, but there are no objects that we are considered. Already 5 objects are completed. So that it is not a solution, but it is this node is not killed. Okay. Now we have to backtrack. Now we have to backtrack. Now we have to backtrack. So backtrack to this one. Here left hand side x suffix 3 is equal to 1. Right hand side x suffix 3 is equal to 0. Okay. Whenever the third object is not considered, the same values we have to write. So that is p value is a 10 and weight value is 4. W value is 4. Now, so sum of the weights of the objects that were considered less than or equal to the capacity of the knapsack. 4 less than or equal to 12. So condition true. So that we have to extend that node. By considering the fourth object, up to now 3 objects are completed. By considering the fourth object, x suffix 4 is equal to 1. Fourth object profit is 8. 10 plus 8, that is 18. Fourth object weight is 4. 4 plus 4, that is 18. After considering the fourth object, the profit value is 18 and weight value is 8. Okay. So sum of the weights of the objects is less than or equal to the capacity of the knapsack. 8 less than or equal to 12. Condition true. So that we have to extend that node. Now left hand side considering the fifth object. Fifth object profit value 4. So 18 plus 4, that is 22. Fifth object weight is 2. 8 plus 2, that is 10. So after considering the fifth object, the profit value is 22 and weight value is 10. Okay. So sum of the weights of the objects that we are considered is less than or equal to the capacity of the knapsack. So that we have to extend that node, but already 5 objects are completed, x1, x2, x3, x4, x5. So we do not extend that node. Now we have to backtrack. Okay. So left hand side x suffix 5 is equal to 1. We can go for right hand side. X suffix 5 is equal to 0. So we are not considering the fifth object, so that whatever the p comma w values are there, the same values we have to write 18 comma 8. Sum of the weights of the objects that were considered less than or equal to the capacity of the knapsack. 8 less than or equal to 12. Condition true. We have to extend that node, but already 5 objects are completed, so that we do not extend that node. But it is not a solution because the sum of the weights of the objects is equal to the capacity of the knapsack. So we can go for backtracking. So now we go to backtracking. Okay. Now here left hand side x suffix 4 is equal to 1. We can go for right hand side. X suffix 4 is equal to 0. Whenever the fourth object is not considered, whatever the p comma w values are there, the same values we have to write. 10 comma 4. Okay. Now, sum of the weights of the objects less than or equal to the capacity of the knapsack, 4 less than or equal to 12. Condition true, so that we have to extend that node. Now, left hand side, considering the fifth object, x suffix 5 is equal to 1. Fifth object profit is 4, so 10 plus 4, that is 14. And fifth object weight is 2, 4 plus 2, that is 6, 14 comma 6. Here up to now 5 objects are completed. After considering the 5 objects, so weight is 6, so 6 less than or equal to the capacity of the knapsack, 12. 6 less than or equal to 12. Condition true, we have to extend that node, but there are no objects that we have to place. Already 5 objects are completed. So that we have to backtrack. Now we go for right child, x suffix 5 is equal to 0. We are not considering the fifth object, so that the p comma w values are same we are getting, because we are not considering any object, so that we are getting 10 comma 4. Okay, so here sum of the weights of the objects that we are consider up to now is 4. 4 less than or equal to 12, capacity of the knapsack 12, 4 less than or equal to 12, condition true, we have to extend that node, but there is no possibility because all 5 objects are completed, so that it is not a solution, so that we go to backward. Backtracking, now we go to 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 backtracking. Okay, so here up to now left subtree is completed. So in the left subtree only one solution we are getting. This is the solution. Sum of the weights of the objects is less than or equal to the capacity of the knapsack. Here capacity of the knapsack is 12. So 12 is equal to 12. Whenever what are the objects that we are consider, sum of those weights is equal to the capacity of the knapsack, then this becomes the solution. Here 12 is the sum of the weights of the objects, capacity is 12, 12 is equal to 12, now it becomes the solution. So this is the profit value 29. Now, so left subtree is completed. So now we go for right subtree. Here one possibility is x1 is equal to 1. Now we go for right subtree, x1 is equal to 0 means, so the first object is not considered. Whenever the first object is not considered, we are getting the same values 0 comma 0. Okay, now sum of the weights of the objects is less than or equal to the capacity of the knapsack, 0 less than or equal to 12, condition true, so that we have to extend that node. So now we have to consider first object is completed. Now we go for second object. Consider the second object. Second object profit is 15, 0 plus 15, that is 15. Second object weight is 6, 0 plus 6, that is 6. So after considering the second object, p comma w value becomes 15 comma 6. Okay, now here 6 less than or equal to capacity of the knapsack 12. 6 less than or equal to 12, condition true, we have to extend that node. Here up to now second object is completed. Now we go for third object. Consider the third object. Third object profit is 6, 15 plus 6, that is 21. Third object weight is 3, 6 plus 3, that is 9. So 21 comma 9. After considering the third object, p comma w value becomes 21 comma 9. So here 9 less than or equal to 12, condition true, so that we have to extend that node. So up to now 3 objects are completed. Now we go for fourth object. x4 is equal to 1 means fourth object is considered. Fourth object profit is 8, so 21 plus 8, that is 29. And fourth object weight is 4, 9 plus 4, that is 13. So here 13 less than or equal to 12. Capacity of the knapsack is 12. Up to now, what are the objects that we are considered? Sum of those objects weights is equal to 13. 13 less than or equal to 12. Condition failed. So that we have to kill that node. So after killing that node, we do not move forward. So again, we have to backtrack. We have to backtrack. Here left hand side is x suffix 4 is equal to 1. Another possibility is that x suffix 4 is equal to 0. Fourth object is not considered. So whatever here fourth object is not considered, so that there is no change in p comma w value. 21 becomes same, 9 becomes same. So here 9 less than or equal to 12. 9 less than or equal to capacity of the knapsack is 12. 9 less than or equal to 12. Condition true. So that we have to extend that node. So what object we are considered now? Up to now four objects are completed. Now we go for fifth object. Fifth object profit is 4 and weight is 2. Profit is 4. 21 plus 4 that is 25. 9 plus 2 that is 11. 25 comma 11. Okay, here 11 less than or equal to 12. Condition true. We have to extend that node, but 5 objects are completed. So that we cannot move forward. Now we go to backward. We go to backtracking. Okay. So after backtracking, so here we are getting 21 comma 9. Another possibility is that here x suffix 5 is equal to 1. Now we go for right, x suffix 5 is equal to 0. That is 21 comma 9 we are getting same. Here 9 less than or equal to 12. Condition true. We can extend that node, but there are no objects are there. Up to now 5 objects are completed, so that we do not extend that node. But it is not a solution. So now we go to backward. Now we go to backward. Now we go to backward. So now go to, so another choice is here x suffix 3 is equal to 1. Now we go for x suffix 3 is equal to 0. So now x suffix 3 is equal to 0 means third object is not considered. Whenever the third object is not considered, same p comma w values are there. So that is 15 comma 6. Here 6 less than or equal to 12. Condition true. So that we have to extend that node. Now consider the fourth object. Fourth object weight is 8. Profit is 8 and weight is 4. Profit is 8 means 15 plus 8 that is 23 and weight is 4. 6 plus 4 that is 12. After considering the fourth object, 15 plus 8 is 23. 6 plus 4 is 10. So 8 comma 4 is nothing but fourth object profit and fourth object weight. So 23 comma 10. Here 10 less than or equal to 12. Condition true. So that we have to extend that node. By considering the fifth object x suffix 5 is equal to 1. That means we are considering the fifth object. So here profit value is 4 and weight value is 2. 23 plus 4 that is 27 and 10 plus 2 that is 12. 23 plus 4 that is 27. 10 plus 2 that is equal to 12. Here sum of the weights of the objects is equal to the capacity of the knapsack 12. Now it becomes another solution 27 comma 12. Okay, so when it becomes a solution, sum of the weights of the objects that we are considered is equal to the capacity of the knapsack. Here sum of the weights of the objects is equal to 12 and capacity of the knapsack is 12. So 12 is equal to 12. Now it becomes the solution. Here the profit is 27. Okay. Now it cannot be moved forward. Now again we have to backtrack. Another choice is x suffix 5 is equal to 0. So here 23 comma 10 we are getting same. Here 10 less than or equal to 12. Condition true, but there is no possibility of extending that node because 5 objects are completed. So again we have to backtrack. Again we have to backtrack. So here left hand side x suffix 4 is equal to 1 and right hand side x suffix 4 is equal to 0. So fourth object is not considered, so that p comma w values is same, 15 comma 6. Okay. So now here 6 less than or equal to 12, condition true, so that we have to extend that node. So by considering the fifth object property is 4 and weight is 2. So 15 plus 4 9, 6 plus 2 that is 8. After considering the fifth object 19 comma 8 we are getting, but here 8 less than or equal to 12, condition true, we have to extend that node, but there is no possibility because all objects are completed, so that we have to backtrack. Another choice is x suffix 5 is equal to 0, we are getting same p comma w value 15 comma 16, 15 comma 6. Okay, so 6 less than or equal to 12, condition true, we do not extend that node because there are all 5 objects are completed, so that we do not extend. So that again we have to backtrack, again we have to backtrack, again we have to backtrack, again we have to backtrack. So here left hand side x suffix 2 is equal to 1 and the right hand side x suffix 2 is equal to 0. Second object is not considered, so that p comma w values are same, 0 comma 0. Here 0 less than or equal to 12, condition true, so that we have to extend that node. Here up to now 2 objects are completed. Now we go for third object. Third object is considered. Third object property is 6 and weight is 3. So 0 plus 6 that is a 6, 0 plus 3 that is a 3, 6 comma 3. Here 3 less than or equal to 12, condition true, we have to extend that node by x suffix 4 is equal to 1. That means fourth object is considered. Fourth object property is 8 and weight is 4. Property is 14 plus 4 that is 8 and 7 plus 6 plus 8 is 14. 14, 3 plus 4 that is 7. Again 7 less than or equal to 12, condition true, so that we have to extend that node by considering the fifth object. Fifth object property is 4 and weight is 2. So that is 14 plus 4 that is 8, 7 plus 2 that is 9. So that is 18 comma 9. So 9 is less than or equal to the capacity of the knapsack. So that we have to extend that node, but there is no possibility because all 5 objects are completed. So that again we have to backtrack. So right choice is x suffix 5 is equal to 0, that is 14 comma 7, same p comma w values we are getting. 7 less than or equal to 12, condition true, we have to extend that node, but all objects are completed. So that again we have to backtrack. So here another possibility is x suffix 4 is equal to 1, left hand side, right hand side, x suffix 4 is equal to 0. Okay, now after we do not consider the fourth object, so p comma w values is same, 6 comma 3. So 3 less than or equal to 12, condition true, so that we have to consider the fifth object. Fifth object profit value 4 and weight is 2, 6 plus 4 that is 10, 3 plus 2 that is 5, 10 comma 5. Here 5 less than or equal to 12, condition true, we have to extend that node, but there are all objects are completed, so that there is no possibility of extending that node. Again we have to backtrack. So right hand side x suffix 5 is equal to 0, so there is no change in p comma w value, that is a 6 comma 3. Here 3 less than or equal to 12, condition true, we have to extend that node, but there is no possibility, all objects are completed. So that again we have to backtrack, again we have to backtrack, again we have to backtrack. So again we go to this one, another possibility, x suffix 3 is equal to 0. That means third object is not considered, so that 0 comma 0 we are getting. Okay, so here 0 less than or equal to 12, condition true, so that we have to extend that node by considering the fourth object. Fourth object profit is 8 and weight comma 4, 0 plus 8 is 8, 0 plus 4 is 4, 8 comma 4. So here 4 less than or equal to 12, condition true, we have to extend that node by considering the fifth object. Fifth object profit is 4 and weight is 2. Here I am not mentioning, there is no place is there. Because of that reason, 8 plus 4, that is 12, 4 plus 2, that is 6. Here 12 comma 6 is there. So here 6 less than or equal to 12, condition true. We have to extend that node, but all objects are completed, so that we have to backtrack. So here another choice, x suffix 4 is equal to 0. Here there are no considering the fourth object, then we are getting 0 comma 0. Here 0 less than or equal to 12, condition true, so that we have to extend that node. Left hand side x suffix 5 is equal to 1, that is fifth object is considered, that is 4 comma 2. So left hand side 4 comma 2 is there, but 2 less than or equal to 12, condition true, we have to extend that node, but there is no possibility because all objects are completed. So again we have to backtrack to this node. So right hand side, so x suffix 5 is equal to 0. We are not considering any object, so that there is no change in p comma w value, that is 0 comma 0 we are getting. Okay, so now left subtree is completed and the right subtree is completed. Left subtree contains one solution and the right subtree contains one solution. Okay, now we go for solution 1. Solution 1, how we are getting these values? From the root node to this node, how we are getting? So here x1 is equal to 1. Here x1 is equal to 1. Next we go for x2 is equal to 1. x2 is equal to 1. Next x3 is equal to 0 and x4 is equal to 0 and x5 is equal to 1. 1, 1, 0, 0, 1. This is we are getting. So here first object profit, we are considering the first object. First object profit is 10 plus second object is also considered. Second object profit is 15 plus third object is not considered. Fourth object is not considered. Fifth object is considered. That profit becomes 4. Whatever the objects that we are considered, so that object profits we have to write. Here 1 is there, the corresponding object profit we have to write. 0 is there, we do not consider that profit. So here 10 plus first object profit 10, second object profit 15. We are not consider the third object profit. We are not consider the fourth object profit. Consider the fifth object profit, that is 4. 10 plus 15 plus 4, that is 29. Now we go for solution 2. Solution 2 here is there. How we are getting? X1 is equal to 0. Next x2 is equal to 1. X2 is equal to 1. Now x3 is equal to 0. Now x4 is equal to 1 and becomes x5 is equal to 1. So 0, 1, 1, 0, 1, 0, 1, 1. Okay, this is we are getting. First object profit is not considered 0. Second object profit, that is 15, we are considered. Third object profit is not considered 0. Fourth object profit is considered, that is 8. Fifth object profit is considered. So that 15 plus 8 plus 4, that is 27. So among that two profit value, our knapsack problem main object is to maximize the profit. What is the maximum profit among them? So maximum profit is equal to maximum of 29 comma 27, that is 29. So 29 profit we are getting from this solution 1. Therefore, so this is feasible solution, this is feasible solution. Among the two feasible solution, which feasible solution has the maximum profit, that feasible solution becomes the optimal solution. So maximum profit is equal to 29. Therefore, optimal solution is equal to this one, 11001. 11001 with maximum profit is equal to 29. So in this way, we have to solve the 0 by 1 knapsack problem using backtracking. Because of space available, I am not writing to here this left child and right child, and this left child I am not writing. Okay, so this is the procedure we have to follow for solving 0 by 1 knapsack problem using backtracking. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa.